Hello guys, welcome to this video. This one is paper October-November 2022 961831. So basically I started explaining this paper without opening the recording. So I'm going to explain it again though. Okay, so question number 1 says that real numbers are stored in a computer system using floating point representation with 8 bits for the mantissa and 8 bits for the exponent and 2's complement form for both mantissa and exponent. Write the normalized floating point representation of plus 202 in the system. Show your working. So this is basically a 3-mark question where 1 mark is for the answer and 2 marks are for your working. Okay, so what you have to do here is that since it's 202, right, you have to create a positive representation of ordinary number 202, right, into binary. So how do I do this? That I know since these are 8 bits, so the place values that we have are 1, 2, 4, 8, 16, 32, 64, 128. Which means that if this one would be 1, of course, and then 202 minus 128 gives me 74, which means if I add 74 more, I can have 202. Now okay, so this will be our number. Okay, now we have to do the correct shifting of bits so that we can expect a mantissa and an exponent. So let me change the color. So now we go by 1, 2, 3, 4, 5, 6, 7, and 8 because the point is gonna be here. Okay, so this would be 2 to the power 8 because we are moving backwards, and in this notation when we are doing this, so initially backwards is positive and forwards is basically negative. So we are moving backwards, so we are going to have plus 8 and this is going to be 2 to the power plus 8. Okay, so our exponent is going to be whatever 2's power is. So this is our exponent. So which means that our exponent is going to be 8. So let me jot it down over here. So 1, 2, 4, 8. So 8 is this, and then all others are 0, 0, 0, 0. And what about the mantissa? Mantissa would be 0 because then there's always an invisible point over here. Okay, so here you have a point, so 0 point because there's the point. Okay, so 0 point 1 1 0 0 1 0 1. Okay, and when you move it back 8 places, you will obtain this number. So hope that makes sense. Now let's get to part B, which says write the normalized floating point representation of minus 202. So this is quite easy. It carries 3 marks as well, but simply what you have to do in such questions is first you have to create a positive representation of the number, and since you already have that, so you don't need to create it. And then for the negative representation, you're just gonna look at the mantissa. Okay, and you're going to take 2's complement of the mantissa of positive 202, while the exponent remains the same because exponent doesn't really matter in this sign thing. Okay, so for this I'll just write the exponent as it is, 0 0 0 0 1 0 0 0. Okay, and then for the mantissa I have this 0 1 1 and then 0 0 1 0 1. So this is my mantissa. Now what I have to do is I have to create first the 1's complement of it and then the 2's complement of this. Okay, so which means that I have over here to take the 1's complement, and 1's complement is basically flipping bits. So I have to just change the bits. Okay, so this is 1's complement. Okay, and what we have to do is over here, oh sorry, this was your number, right? So it was like 1, wait, yeah, this is your mantissa, right? Now you have to just flip the bits over here. So this is going to be, let's use another color so that it's more clear. So for 1's complement, what I'm going to do is I'm just going to flip bits. So 0 1 0 1 1 0 1, sorry, 0 0 and then 1. So it's going to be 1 0 0 1 1 0 1 0, and then I'm going to add 1 in this. So this gives me the 2's complement. Okay, and when I add this, it's 0 plus 1 1, and then all others are 0 0 1 1, right? So this gives me the number Now this gives me the number. Let me change the color again. So it gives me 1 0 0 1 1 0 1 1. So this gives me the representation of negative 202 in this system. Okay, so I think it's pretty simple. You just have to take the 2's complement of the mantissa, and that's it for this question. Okay, then for the part C, okay, there's a part C as well, sorry. So the binary number is stored in the computer system. Okay, this is the binary number. State why the number is not normalized. So for the normalization, since I told you there is an invisible point over here, right? So for normalization, the 2 bits before and after point must be different. Like either it should be 0.1 or it should be 1.0 for normalization. Why we need normalization? So that there is only a single representation of a number, and then there are no redundant zeros in the mantissa, which are, you know, redundant zeros leading in the mantissa. So we need a normalized representation for that, so that we have a number which is more accurately represented. Okay, so here we can write any reason, any suitable point, like why the number is not normalized. So we can simply state that the first 2 digits are the same. Okay, so the first 2 digits are the same. Okay, write the normalized floating point representation of the number. So normalized floating point representation of the number. So for normalization, we have stated the condition. Now to normalize this, we have to move this bit in such a way that after point there should be 1, right? So it is like 1 2 2. You have to move 2 places so that we can have you know, a normalized mantissa, a normalized representation of a number. So this is going to be 0, okay, 1 1 1 1, and then all the zeros over here. For the exponent, so initially we have the exponent 1 2 4 8 16. Okay, so 16 plus 8 is basically what? It's 24. Yes, 16 plus 8 is 24. And so the exponent that we initially have was 24, and now since we move 2 places ahead, and this one is negative because we are moving in the front. This is opposite of what initially we have in math. Okay, so this means that it is minus 2, right? So this is going to be 22, which means our exponent is now going to be 22. Okay, so this is 1 2 4 8 16 16. So 16 plus 4 is 20, and then 22. 16 plus 4 is 20, and then 22. So you have, okay, put the zeros over here, and then you have this as your exponent. I hope this was clear. Okay, now let's proceed on to question number 2, which is quite interesting. I'll use another color over here. So this is something you need to learn with concept so that you can score an easy 5 mark. Okay, so outline the functions of the transport layers of the TCP IP protocol suite. Transport and internet layers, sorry. So for the transport layer, transport means that each day, like for instance, if we connect it to a real life term, it means that when we are moving to a place, say we are going to school, okay, you are being transported to a place, right? Similar case is of data. Okay, so transport layer basically sends the packet to the internet layer. But first, what does it do? It basically, like your van, for instance, picks up kids. Okay, like it doesn't take only one kid to the school. Okay, it picks up different kids. So I'm just trying to link it to a real life application. If that seems a bit weird, then please ignore it. So for the transport layer, you're first going to write that it breaks data into, you know, manageable packets. Okay, so there's I don't know if you have ever traveled, so in that case vans have those shifts, and those shifts are like, I think, data packets. Like you have to break the amount of kids into some packets, like okay, these kids will be in this shift and these number of kids will be in that shift, but I think just ignore it at the moment. So what does the transport layer do? it breaks data into manageable packets. Okay, what's the spelling? Yeah, okay, I think that's the correct spelling. Okay, fine. It breaks data into manageable packets. Okay, first the breaking of data is done, and then what it does, it sequences the packets. Okay, it sequences the packets, like which child to drop first if you all have different schools or you have different homes. So first it breaks data into manageable packets, and then it sequences the packets, and after that it basically sends the packets to the, this is a very common question, so make sure you know that it sends the packets to the internet layer. And then, okay, for this I think it was 3 points for each was enough, but I'm writing just in case another one as well. So it breaks data into manageable packets, and it sequences the packets, and then it sends the packets to the internet layer, and then it handles packet loss. It handles packet loss since it acknowledges the receipt of complete error-free packets, right? So if a packet has been corrupted or lost, so it handles that situation. Okay, so this is it. And for the internet layer, now you can always write that it sends the packets to the subsequent next layer, which is basically, you have like this now, there's this application layer, and then there's this transport, and then this internet, and then data link, right? Data link. So you can always write for each of them that it sends the packets to the subsequent next layer, and you have to state which layer. But okay, like this, so this is here and this is here. So okay, you can always do this, but you'll get 1 point for this though. Okay, so what does the internet layer do? So internet layer identifies the intended network and host. Okay, so internet layer means obviously it's going to be dealing something with networking and host and everything like that. Okay, and it transmits the point I told you before, that it transmits packets to data link layer, packets to data link layer. Okay, and then for the third point you can write that it routes the packets independently through the optimum route, the best possible route, so that they are transmitted more effectively and efficiently. So for this I can write it routes the packets, so each packet can take a different route. Okay, it routes the packets, but they're reassembled at the receiving end. Okay, so it routes the packets, okay, independently through the optimum route. Okay, I think there's no more space, but you can write as many points as you not as many points. You can write these 3 points, but if any other is suitable, so you can always write that one. Okay, but make sure you correctly address each question specifically. Okay, like you can write that it uses IP address and port number to form a socket, or it addresses packet with their source and destination IP addresses. Getting it? So you can write anything like that. Now let's proceed to question number 3. This is a very easy question. You can easily gain a lot of free marks from here, honestly. So let's do it. Let's change my pen to make it more colorful. Okay, what is meant by enumerated data type? So basically this data type is it is a non-composite data type. It is a user defined data type. Okay, you just have to learn the definition because you can easily score 1 and 2 marks, so that's great in this paper. So what is meant by enumerated data type? So it is a data type, or you can write user defined non-composite data type, composite data type with known values, okay, with an ordered list of possible values or known values, okay, with an ordered list of possible values. I'll show you the example over here. Okay, so a user defined non-composite data type with an ordered list of possible values. And what is meant by the term pointed data type? To pointed data type is basically it is always pointing to a specific address or a memory location. Okay, you need to state this as well. So now no sorry so this is and over here in part A, it is important to write this thing, an ordered list of possible values, because whenever we are making an enumerated data type, say of days of the week, so we have to make sure it is in order, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, like this. Okay, and what is meant by a pointed data type? So basically it is a user defined non-composite data type used to reference or point to a memory location. So this is more important over here. Then for the part C, okay, let me just increase the brightness. The months of the year are January, February, March, April, May, June, July, August, okay, whatever. So you have to write the pseudocode statement to define the data type Q1 to hold the names of the first 3 months of a year. This is of course enumerated data type because since you have the known values, okay, but make sure that is ordered. Okay, so for this there is a specific syntax, and you have to always write type and then the variable name, which is Q1. This equals to, then you have to put on the brackets. They can be normal brackets, okay, but make sure you follow this syntax. Okay, and then you have to write the first 3 months. Obviously these are January, February and March. Don't write and March, and you don't add over here these strings, because in enumerated we don't do that. Okay, we know that this is the value January, February and March. Okay, now you are through with it over here. Now for this, the composite data type PET is used to store data about various pets of a group of students. It uses this fields. So it uses what? It uses wait, okay, I think the light is less. I should open. This is fine. Yeah, okay, I think this is better. Just a second. Yeah, it's better now. Okay, so the composite data type PET is used to store data about various pets of a group of students. It uses this fields. So what are the fields? Okay, these are the fields: pet name, animal type, okay, blah blah blah. So write the pseudocode statement to set up a variable for one record of the composite data type PET. So you can name it anything like my pet. Okay, so declare. This is just a pseudocode statement, make sure. So this is declare my pet. Okay, this is my pet, and my pet is pet. Okay, so this is done, and then what you have to do is write pseudocode to store the details of the following pet in the variable you have set up in D1. So simply you have to start writing by my pet. This is the syntax of a record data type, right? So this is going to be my pet dot pet name. Make sure you use the same variable name. Okay, my pet dot pet name. Now simply assign the values. Okay, this is going to be Tibbles, Now see, pet name was basically a string, right? So you need to include these. So this is going to be tables, and then my pet dot animal type. This was also string, I guess. Cat. Then my pet dot pet age. This is obviously an integer. And then my pet dot pet gender. This is a character. Okay, M. And for owner name, my pet dot owner name. This is going to be Jasmine Smith. I hope this makes sense. This was a very easy question. You can easily score 3 out of 3 in this. Alright. Let me check the data types are fine. Yeah. Okay. Draw one line to connect. Let me change the marker again. Okay. Draw one line to connect each stage of compilation to its most appropriate description. Alright. So the stage of compilation is this, and this is the description. So just to review these states, let's get out of the question for a minute. So whenever you are studying about the stages of compilation, right? So the first stage is always this lexical analysis, where you are basically converting a sequence of characters into a sequence of tokens. We are back to the question though once again. Okay, so let's explain it in parallel. Okay, this is an order, by the way. So first we perform lexical analysis, then syntax analysis, then code generation, and then code optimization. Okay, so for the lexical analysis stage, what we do is we remove those extra comments. Okay, and is the light okay? Yeah, it is okay, I think. So lexical analysis, what it does, it converts a sequence of characters into a sequence of tokens. Okay, tokenization and creation of those token tables. Okay, this is all in lexical analysis. Then what does syntax analysis do? Now this is the most easiest thing, I think, because syntax is what it is, a way you are writing the program, so what does it do? It just makes sure that program follows the correct syntax of the programming language, the code that you have written, and it does this by using parsing algorithms to interpret the meaning of the sequence of tokens, okay, which were created in this lexical analysis. And code generation is what it basically converting an intermediate representation of source code into an executable form. And optimization, what does it do? It basically, this is quite easy, minimizing a program's execution time and memory requirement. Okay, all right, so this one is left out. Okay, so this was the question number 4, worth 4 marks. So let's get on to question number 5. So we have almost a total of 12 questions on this paper. Now question number 5. Okay, so yeah, write the Infinix expression in reverse Polish notation, RPN. Okay, so for this, Infinix expression is what we humans can understand or interpret. Okay, but for the computer we need to have this RPN notation. And for RPN notation, what do we do is that we have to use this thing, baud mass, for this purpose, baud mass. Okay, and for the baud mass rules, it means these are some rules of precedence. So you always know that this multiply has a greater priority in as compared to addition and subtraction, right? So what we're going to do is, but also when we are doing this RPN, so expressions are always evaluated from left to right. Okay, so we're going to start with A, B, and then multiply. All right, and then since addition and subtraction have the same priority level, so what we're going to do is we're going to do this like AB is multiplied. Okay, and then what is happening over here, like and then this thing is added with B. right? So what we can do is we can simply write B and then plus. Okay, that's what we do. What do we do is like, yeah, we first write these alphabets and then we write the sign over here, right? So A and B are basically multiplied. You can also check this using a stack, that what if you write A and B, okay, and then you apply this multiply on this, so what will happen is A and B will be multiplied, right? And then B, since these have the same priority, so then we'll write B, this one B, this I'm talking about this one, so this will be plus, and then D would be obviously after we write D, and then this would be minus. Okay, and then 15, obviously 15 will be written here, and this would be plus. So I hope this makes sense how it's going on. And then write the RPN expression in infinix form. Okay, now this is more easier. How? Because you can obviously you can just evaluate it using stack. If I just use another pen over here, so what do I do is I make a stack over here, and I I push A and B, and then what I do is I apply negative sign. So what will happen is A and B will eventually be subtracted, right? This will be A minus B, and then what I'm going to do is I'm going to add in A minus B over here, whatever the value was, and then I'm going to add, okay, and then I'm going to add C over here, right? C and D, okay. And then when I apply this plus, so what will happen is C and D will be added. So what I'm going to write is C plus D. Now this would become A minus B and C plus D. Now when I apply this operator, which is multiplied, it means that these two values will be multiplied by each other. Okay, so let's put the bracket over here, and then they would be multiplied. And then, okay, let's say when these two are multiplied, let's say this is x. Okay, x is equals to, when they are multiplied, so we are just representing it with x. Now this x you will add A, and then when you apply this operator, this whole thing is going to divide with A. So this is your infinix notation. Infinix form. Yeah, this is it. Now evaluate your infinix expression from part B1 when A is equals to 5, B is equals to 7, C is equals to 27, and D is equals to 12. So what you're going to do is this is going to be 5 minus 10 multiplied by C plus D is 27 plus 12 divided by 5. So 5 minus 10 is negative 5 multiplied by 27 plus 12 is 7, 8, 9 and 39. 39. What I am doing over here? Yeah, okay, fine. So this is 39 into negative 5, and then you are going to divide it by 5. So what is going to happen here, that 5 cancels out, so it's going to be minus 39. Yeah, I'm doing it correctly. So a message is encrypted using a private key. Okay, this is now question number 6. A message is encrypted using a private key and sent to an individual using an asymmetric encryption. Now, asymmetric encryption uses a pair of keys, which are the public key and the private key. Okay, and for this one, just a minute. Yes, for this one, what is meant by a private key? Okay, so private key. Now, this is a very easy question, I must say, because private is what? Private is something which is secret, right? It is a secret key, so you can simply write that it is a secret key. Okay, number 1, you need to write 2 points over here, so you can write it is a secret key. And then for the second point over here, we can write obviously this is used for description, right? But what does it decrypt? So it is used to decrypt a message, okay, or any data, okay, that was encrypted with its matching public key. Okay, so imagine this was a person A and this was a person B. Okay, so they both have a pair of keys, right? A public key. So this person has a public key, this has its own public, she has her own public and private key, right? Let me use this pen. Okay, so we have this one, right? So first what they do is, if this user wants to send a message to this user in asymmetric encryption, what does he do is they exchange keys. So this key, which is of this person, goes over here and it is used to encrypt that message. Okay, this was, say, the message and it's locked now. Okay, it is used to encrypt this message, and when this message is sent, so this message is decrypted with its matching private key. Okay, the same so the pair of key, yeah, okay, it is used to decrypt a message that was encrypted with its matching public key. Yeah, okay, now fine. Now so that's what I was saying, that is used to decrypt the message that was encrypted with its matching public key. So this was the matching public key, right? This was the matching public key. So it is going to decrypt this message which was, yeah, encrypted using its public key. Yeah, exactly. So that's what I was saying. Okay, describe the process of asymmetric encryption. Oh, I already did that, but for just the writing sake, I have to write this. All right, the message to be sent is encrypted using the receiver's public key, and then what happens? Okay, it is encrypted using recipient's public or the receiver's public key, and then it is used to the message is decrypted using the receiver's private key. So you need to make sure that what does this pair of key do, because in asymmetric encryption what two people usually write is that it uses a pair of keys. So but how does it uses the pair of keys, right? So you have to make sure to describe the process. Oh, we have this question as well. So explain how a digital signature is used to verify a message when it is received. All right, so I think this needs a detailed explanation though. So what does it do is a digital signature is used to verify a message. Okay, so this is something that deals with the verification of the sent messages. So what does it do is the message together with the digital signature is decrypted using the receiver's private key. So this, let's just draw it over here. This is a message, okay, and it also has, say, the digital signature. Okay, this is the digital signature. So this is basically decrypted, okay, using the, let me use another color, receiver's private key. This is basically receiver's private key. Okay, and then what happens is the digital signature received. Now this was the, let me use another color. Now this digital this digital signature received. What about this? When you have decrypted this whole thing, right? So what you obtain is, you obtain a message and a digital signature, right? So this thing is basically decrypted using the sender's public key. This is something you need to learn, honestly. Public key but make sure you understand this. Okay, so first what you do, this message together with the digital signature is broken down. It is decrypted using receiver's public key, and then you obtain a message and this digital signature. So what do you do is you decrypt this digital signature received with the sender's public key. Okay, and this is done to recover the message digest sent. Okay, so this basically recovers the message digest. Okay, and for this one, which was the message, okay, so message is basically hashed with agreed hashing algorithm. Okay, so to to reproduce the same message digest, no, not the same, but the message digest of the message received, right? So this is put into, say, a hashing algorithm, and then what does it do? It also produces a message digest of the message received. Now this was basically the one which was sent, and this is what message digest which was received. Now if the two match, then the transmission can, then you can say that okay, the message is not altered and it is the same as what was sent. Okay, so if we just now write this down with another color, let me take this one. So we'll simply write it as the message together with the digital signature. You can write any 4 points though, is decrypted using receiver's private key. Okay, so private key is used to decrypt this whole package. Okay, and then what happens, that you obtain these two things, right? So the digital signature, I'm writing these short form. Okay, received, you don't do this, right? Full signature. Okay, I don't have space over here. The digital signature received is decrypted with the sender's public key. Now make sure that over here this is a bit different when we are obtaining a message digest, right? To obtain the message digest sent. Okay, so digital signature, this is something you always do this, you decrypt messages with your private key, right? But when we are talking about digital signature, which is used to obtain the message digest sent, it is always decrypted with the sender's public key, and it is encrypted with the private key though. Okay, so for here for this question you need to know this. And then the decrypted message received, now this message is also decrypted, right? So the decrypted message received is hashed with agreed, make sure the hashing algorithm is agreed though, like you have to use the same hashing algorithm at the receiving end as well as the same hashing algorithm when it was being sent. Okay, so the decrypted message received is hashed with agreed hashing algorithm to reproduce the message digest sent. And then you can simply write that the two message digests are compared, so you get 1 point for this. And then for the second point you can also get for this is that if they match, so obviously the message has not been altered, simply like that. Okay, I hope that was clear. Okay, then for this question number 7, complete the K map for the Boolean expression. Okay, so for this one, okay, so this is the last question I'm going to address in this part of the video. I'm going to make another video addressing the next 3 questions, I think 3 to 4 questions, because the video is getting very long. Okay, so let's do this. This is very easy though. Complete the K map for the Boolean expression. So what do you have is over here that whenever there's a bar on top of any letter, so which means this one is 0, right? So let's divide this into groups, right? So one group, second, third, fourth, fifth. Let's divide it into groups. Now what do you do is, now this is 0 1 0 0, this is 0 1 0 1, this is 1 1 0 0, this is 1 1 0 1, this is 0 1 1 1, and this is 1 0 0 1. Now what you have to do over here is that this is going to be, now you have to simply just jot this down over here, right? This is going to be 0 1 and then 0 0 1, and then 0 1 0 1, right? 0 1, where is that? And then 0 1, yeah, this one, and then 1 1 0 0, this is going to be this one. Oh sorry, not this one. 1 1 0 0 is going to be this one, sorry. 1 1 0 0, and then 1 1 0 1, this is going to be this, and then 0 1 0 1, and then 1 1, yeah, this is going to be this, and then 1 0 0 1, this is going to be this. Wait, I think I've done a mistake over here. This is 0 0 1 0 0, then 0 1 0 1, and this is 1 1 0 0, this is 0 1, yeah, this is all 0 1. Oh no, this is 1 and this is all 0 0 0, and this is 1 0 0 1, right? So this is going to be what I have done over here: 0 1 0 0, and then 0 1 0 1, and then 1 1 0 0, and then 1 1 0 1, okay, and then 1 0, and then all zeros, okay, this one, and then 1 0, and then 0 1, yeah, so this is a 0, then all others are 0. I hope that makes sense. Do it very carefully, okay? And then you have to draw loops around appropriate groups in the K-map to produce an optimal sum of products. So let's draw those loops. So that's going to be, okay, the loops are always of the number of ones are something which is 2 to the power something, which means you can always have 2 1s, 4 1s, 8, 16, like that, okay? And overlapping is a must where necessary. So this is going to be this and this, okay? And then you have to write the Boolean expression from your answer to part B as a simplified sum of products, and use Boolean algebra to give your answer in its simplest form. So the simplified sum of products for this one, this group, this whole thing is what? So for this, we can see that if A is 0 or 1, it doesn't matter what the, it doesn't change the output, right? So if a letter has 0 and 1 and it does not change this output, which it means that if it is 0 and this A is 0 over here and A is 1 over here, it doesn't matter, it doesn't change this output. But when B should always be 1 to obtain this output, so you'll write B, it doesn't matter, so just leave B, and then dot, this is always addressed with a dot, and then over here C always has to be 0 in order to obtain this output. So this is going to be B dot C bar, and then plus, you have to add this plus thing over here, and then, oh, you didn't need the brackets though. And then for this, first I was looking over this loop, and this is the another loop. So for this loop, let me use a different color. This is 1 1, which means A should always be 1, so A matters, and then B doesn't matter because it can be 1 or it can be 0. And for here, D doesn't matter, but C does matter. So it's going to be dot C, right? Okay, C should always be 0. Okay, so now when we simplify this, we can simply write it as C bar A plus B, because this can be A dot C bar and then B dot C. Okay, I hope that makes sense. If anything was still unclear, then do tell me in the comments section below, and please subscribe to the channel and share with your friends and family, and stay tuned for the next part.